I hope you were able to actually read the items on the previous slide and refresh your memory about inverse functions in general. If you need a little more of a refresher, then you can refer back to lesson 5.6. Like the other inverse functions, inverse trig functions do work backwards. We know the answer, we're going to try to find the input that made it happen. So for example, the original sine function. We put in an angle, any angle we want, and we get back a ratio. A ratio that's between -1 and +1. So whatever angle we put in, that's a member of the domain. And whatever angle we get back, whatever ratio we get back, those are all members of the range for the original sine function. If we apply the inverse sine function, we know the ratio. That's supposed to be an n. And we are asking, what was the original angle? That produced it. So for the inverse sine function, the ratios are the domain, and the angles are the range. So like all inverse functions, the domain and the range have been switched. And that makes their graphs reflections across the diagonal line. And if we are trying to solve for an inverse function, we can sometimes switch the x's and the y's. You've already used the inverse trig functions when you were finding a missing angle in right triangle trig. Whoa. Trying to hurry too much here. So if we're given this triangle, we're supposed to find that angle. With respect to the missing angle, the 12 feet is the adjacent side. The 20 feet is the hypotenuse. Adjacent, hypotenuse, could also kotoa. We would be using the cosine of our mystery angle. Has to equal 12 divided by 20. And then you already knew enough to use the inverse keys on the calculator that the inverse of 12 over 20 is going to tell us our missing angle. And with the calculator helping us out, we find out that theta is approximately 53.1 degrees, or about 0.827 radians. A note about notation, which we had the same issue when we were studying just plain old ordinary inverse functions. So this notation means the inverse of cosine of theta. It does not equal the -1 power. If we want to take the -1 power on the cosine of theta, we have to say cosine of theta, whole deal, raised to the -1. And that -1 power means the reciprocal. And the reciprocal on the cosine of theta already has its own name. That is the secant of theta. To try and distinguish between these two notations, some of our ancestors came up with a whole different way of writing it. Whole new set of names. Inverse cosine of an angle can also be written as the arc cosine of the angle, which is abbreviated arc cos theta. And it means the angle with this cosine value is what? Basically, find the angle with this cosine value. So if they ask us for inverse cosine of 1, that is the same as arc cosine of 1. It's supposed to be a double C here. It didn't turn out too well. The angle with a cosine value of 1. Is what? You should know what the angle with a cosine value of 1 is. Because cosine, that's the x divided by the radius. And when the x divided by the radius is 1, that means that the x value is also 1. And on the circle, that's going to happen right here. This angle would be 0 degrees. The x-coordinate is the same as the radius. That happens at 0 degrees. Or, can't forget, 0 radians. Or 360 degrees, or 2 pi radians, or 720 degrees. There are going to be multiple angles with this cosine value. And we will deal with that in one of the later videos. Likewise, inverse sine is also called the arc sine of the angle. And inverse tangent can also be called the arc tangent of the angle. Let me try to go squeeze a C in here. Arc sine, arc tangent. So if they ask us for the arc sine, I do not want to put that C in there, of 1, they're asking the angle with a sine value of 1. Is what? Well, I'm hoping you know around the circle here. Sine is the y divided by the radius. So the y value is going to be the same as the radius right up here. That would be 90 degrees or pi over 2. And you know what's going to come next. Who has an arc tangent of 1? So the angle with tangent of 1 equals what? So tangent, that's sine over cosine, y over x. So sine and cosine, when you divide them, come out to be 1. That can only happen if these two guys are the same. So I'm hoping you remember that that is 45 degrees also known as pi over 4. So that would be right here. And truth be told, 45 degrees is not the only place that the tangent is 1. Also, over here, at 225 degrees, the tangent value is 1. And this fact that there will be multiple angles with the same sine, cosine, and tangent value is something we're going to discuss in a later video. Right now, I'm going to try a few of these. You will need a calculator, and I hope you were able to print out the worksheet that said simple inverse practice.